This is chapter number 3, the loop control structure. Any programming language, the loop is very important. Why? Because the main idea of a computer or your software is to repeat some actions again and again without draining out. Means we are a human, we do something and then we have a body, then after some time we need rest. We encounter fatigue, but computer science and software does not. How can we achieve this repetitive act? This is done through looping construct. Every programming language has loops. They all have loops. So loops, as we said, we want to do something, some set of instruction, we need to do them repeatedly until some condition is met. So we have in C 3 major looping construct: for statement, while statement and do while statement. We'll start with while, then we'll subsequently discuss the for in quite detail, and then we'll go to do while. The while loop. What is while loop? While means till then. Till something is true or till we want something to be done again and again. For example, you want to enter salaries of 10% or you want to convert the temperature from centigrade to Fahrenheit for say 15 city. This can be 150 city. This can be 1500 city. Or it can be 150000 city, means 15,000 cities. This can be done through loop. We are talking about while loop. While loop is an entry control loop. Let us see how it works. We say that we have to find out the simple interest. What is the simple interest? In mathematics we know the simple interest is given by P into R into T by 100. P is the principal, R, that is the n here, is the time, R is the rate of interest. We want to enter for 3 people. We want to find out the simple interest for 3 entries. Say 3 entries. We start with the first person of first entry. We check whether this first entry is less than equal to 3. We have not reached 3. Okay, we have not reached 3. So we go ahead. We ask for PRT, that is PNR here. Then we compute the simple interest and then we print the simple interest. After that, we increase this count. We increase this count and we again check after moving from here to here. We check whether this count is less than equal to 3. That is, we have not reached that 3 level mark. That is, we wanted to do it thrice. So we have just reached twice. Means only once. So we have reached twice. So we have to do it again. Then again the count will increase. We come here and it will be 3 less than equal to 3. Again 3 is equal to 3. So we again go back and perform this activity from here to here. This is the activity. These are the instruction will be inside your while loop, and this will be executed again and again. So this will be done, and once you reach here, you increase the count, it becomes 4. Now 4 is not less than equal to 3. So we go here. That is, now we have to stop. So now what we have done, we have run or executed this instruction thrice. We wanted to, and after that we have come out because our task is complete. If we want to see the program, then this is a main. We want to calculate the simple interest of 3 sets. We entered, or we have made the variables like this. We started with the count. Now this is the while loop. We are interested in learning while loop. So this is while loop. This count, which when it is less than or equal to 3, less than or equal to 3, we enter the PRT, that is the principal, the time and the rate in P and R. We find out the simple interest, compute the simple interest, and we show it. After that, we again increase this count which we started here. This will be incremented, and this will go again back here, and this condition is still not met. So this will be false. This will be thrice false. That is, we wanted to run it thrice. This will be thrice false till this 1 reaches 2, 2 reaches 3. So for 1 false, 2 false, 3 false. But when it reaches 4, this condition becomes actually, this is true. Then when this condition becomes actually true, when count this, because what I am trying to suggest to you is symbolic. Why I said that it is false, this condition is false, that means we want to enter it. But when we want to say that is true, that means we want to come out. That is symbolically you must understand. But what this means is count, let me explain you, less than equal to 3, 1 is less than equal to 3. So 1 is less than equal to 3, this is true. That is why I am saying true. When this condition becomes false, for 4 it will be false. 4 is not less than equal to 3, that will be false. And we come out. This is how it is being done. So if you enter 3 values, you will find out that it will run for 3 times when this condition remains true. For us, when we enter here, we wanted this not to be true because we wanted this to be run thrice. I hope you got the idea. So this program execute thrice, 3 times, and the body of the loop will be run thrice till the condition does not meet its end. So we are incrementing. So let us see. We started we initialize count equal to 1. We tested the condition and this condition was true. So when it became true, we entered the body of the loop and we incremented it again. We incremented it again and again checked with the test condition. And we did it again and again till the condition becomes false. If the condition becomes false, we come out. There are tips and traps. The general form of while is something like this. We initialize the counter, so there is initialization. There is a testing condition for true and false. And there is an increment loop counter. And here we do the activity. These are our instructions. We want to repeat it again and again. So this while loop, this will be run again and again till this condition is true. When this condition becomes false, we come out of the loop. Okay. Then we can have inside this while the syntax is like that, while you like, this is in small letters. Then you have round brackets. Inside this, you can have relational as well as logical operator. The only thing is the result should be true or false. It should be either 0 or any number other than 0. This statement within a loop, it can be a single line. Means if you want to just execute one line, you don't have to give these braces. Means this can be ignored or avoided if you just want one line to be executed. But if you have more than one line, 1 plus, you have to keep those lines inside your brace. Then the while loop must test a condition that will eventually become false. Otherwise, this loop will go on and on again. See here, we have I equal to 1 and I less than equal to 10. But we are printing I and we are not incrementing this I. If we are not incrementing, I will remain as 1. So 1 will be always less than 10. 1 will always remain less than 10. So this will go on for indefinite time. For that, we have to add this I equal to I plus 1. This makes this program credible. You can also use, instead of incrementing a loop counter, you can decrement also. Incrementing and decrementing both are possible. Whether it be while, whether it be for, whether it be do while loop. Then you don't need necessarily only the integral value. You can have a float value. In this program, we are incrementing the A with a float value, that is float increment value 0.1. So it will go from 0.1, 0.2, 0.3. So it will start from 10. It will go to 10.1 till it reaches 10.5 and above. Till the time 10.5 it will run. When it becomes 10.6, it will come out. Means at this point, the condition becomes false and you come out. Even the floating point number or loop counters can be decremented, as we just saw. So what will be the output of this program? Just assume that integer take 2 byte here. What will be the output? The numbers from 1, 2, 3 to 7, 6, 7 will be printed. Okay. This is the general observation of this program. But okay, this is right. I assume that is right. Now keep that thought apart. Let me tell you that if this reaches 32768, we have the range of, if we say 2 byte of integer, then this is 32767, and on the negative side it is minus 32768. So when it reaches above, because at this point you have incremented and you are checking it this value, so this I will be 32768. Okay, this will be 32768. Now when you go beyond 32767, it will not go beyond, it will come back again here. So this will be an infinite, because minus 32768 will come, again it will be incremented, so it will go here, it will go like this, 0, then it will again increment, and this loop will go and on, because you have just checked. You just have to check it till this value should be like this. Then only you will get the result from 1 to 32767. Otherwise, this loop will go on and on again. That is the discussion here. What will be the output of this program? I is 1, I less than 10. Then you are incrementing. But here is a catch. We don't put semicolon after while. If you put a semicolon after while, this line means while. After this, you are not putting any instruction. That is, this is a null statement. You don't want anything to be done. So this portion and this line, they are not related. So this will be an indefinite loop. Because this increment is not related with while now, because you have already kept a semicolon. You have separated these two parts. This is not a part of while now. So this will be done, executed again and again, and it will be indefinite loop. So this is the discussion. You have actually given a null statement here. For that, you have to remove this semicolon in order to actually execute this kind of statements. We have more operators. If you want to print a number, say 1 to 10, this is the simple idea. Start with 1. This is the initialization. While this is the checking condition. This is the increment condition. So what you are doing here is initialization, checking, and increment. So this is true. Now, this is I++. We said I equal to I plus 1. We have to write so many things. Why not to, have some shorthand? Why not to have some operator that does exactly like this? So I++. This is a post increment operator, and I plus plus is exactly equal to I plus 1. They both are exactly similar. So plus plus is post increment operator, and it does exactly the way I plus 1 will do. So you can write this also. Never use plus plus plus. This is not recognizable. This, if you write I plus plus plus, this is unrecognizable by C. Then you can also write a shorthand operator. I'll say how to write this. I equal to I plus 1. Then how you can write this? This is a shorthand, and this is not only shorthand for plus. This can be for any operator, even for modulo operator, division operator, multiplication operator. So how you have to do it? Just place I here, put plus here, take this is equal to or assignment here, and put 1. You wanted to increment by 1. If you wanted to increment by 2, put I plus equal to 2. You want to increment by 0.7, make it I plus equal to 0.7. This is how it works. So this plus is equal to is called the compound assignment operator. So we can have j plus equal to 10. You can have j minus is equal to into is equal to division is equal to modulo is equal to. So this I modulo is equal to say 5 is nothing but I equal to I modulo 5. They both are similar. This is just a shorthand. Now this increment operator we don't have here. Means increment, not increment operator, but increment condition is not here. But we don't need it because we have already incremented it here. So this is also possible. You can write I plus plus, and this is similar to I equal to I plus 1. So when you are incrementing here, you don't have to write any increment here. This is also possible. This is the post. This is the pre. See, plus plus I. I'll tell you the difference. Plus plus I and I plus 1. So what will be done here? If I say I have say x here and x, I has a value 10. So when we say the pre-increment operator, this will go for minus minus I also. Same. Okay, discussion and logic goes for I minus minus also, and I plus plus. This plus and minus minus. Okay, these are pre-decrement operator. This is post-decrement operator. So if we have 10, first what will be done? This I will be increased. First I will be increased, then it will be assigned to x. So I will increase, that will become 11, and now x will have 11 value. In this case, first I will be assigned, that is x will have 10 value, and this I will then increase. So if you use this I afterwards, you will get 11, but when you are assigning it, you will get 10. This is the only difference. Means, let me tell you again, this post incrementation, increment of I will take place after its usage. Here, this is the pre-increment operator. That means the increment of I happens before its usage. The for loop. See, this for loop is very important because the setting up of loop counter or the initial value, the testing of the loop counter, and increment and decrement can be done in one line. Unlike while, where we have you can say 3 separate lines. One is for initialization, one is for checking the condition, like while inside this we had condition, and after that we had increment or decrement. All these 3 can be combined in one line. This is possible using the for loop. So the general form of for statement is like this. For, here we initialize the counter, test the counter, and increment the counter. Any counter, you can also increment or decrement the counter. These all parts, as you see along, when we discuss it more, you'll see all these are optional. It is not necessary to give them, but this is the format. This is the general syntax of a for, and I just urge you to follow this syntax, because there are so many possibilities we are going to see where these all are. They can be avoided. They can be skipped, right? And here inside this for, we execute our operations or instructions. So let us write a simple interest program, and we have already written this program in while. Let us see the flow chart. First of all, what we do here, we start. We say count equal to 1. Then we increase the count. First of all, we just from here, count equal to 1. We check for count less than equal to 3. We'll come here later. So count is 1, we increment. If this is being checked to whether it has not incremented or it has not increased up to 4, this condition remains true, and we will input the P and R, and simple interest can be computed, and we come out. But when we did it thrice, this counter will increase to 4, and now you have to come out. This is how it is done. So this is not very self-explanatory. I'll show you how we do it in the program, actual program. So this is calculation of simple interest of 3 sets. So we want these instructions from here to here. We want these instructions to be executed 3 times repeatedly. So we have taken integer and float. We start with a counter, count equal to 1. We check this counter to be less than equal to 3. Then if it is less than equal to 3, then we print, scan the PNR, calculate the simple interest and print it. Again we go back. We increase the counter now. And now we compare this increased counter with 3. Again we find that the counter is still less. Previously it was 1, then it became 2. Again it will go on. Now the counter will again increase. This will be execute it once again. So the counter will be 3. Again we see that there is this condition does not become true. It is still the counter is actually less than naught. It is actually equal to 3. So we again go ahead. We execute these statement for the third set. Then the counter will again increase and we'll check it. The counter has gone to 4. This condition is met. So we will not go inside. So this is how we do it. For and while loop, they both are entry control loop. That means the checking is done for the condition when we enter the loop. So initialization, testing and incrementation all is done at the same line. Okay. So when we execute this for statement first time, we initialize the value as 1 in this example. We went till 3. Once the 3 is achieved, we come out. This is how for loop goes, and in one line we can find out that all the 3 conditions can be seen. We start, then we initialize, then we test. If it is true, we perform the execution of the loop. Increment, check again. It is true, again we go ahead. Otherwise it is false, we stop. So this is very important to note that these 3 all are the part of this for. But for loop, while loop, do while loop, they are exactly similar. They have minor differences, and where to use them is again the question of practice. How much you practice, you will realize which loop to be used or employed when. But they are all similar. In order to increment, we have seen that we have done certain program. We actually incremented. Now we can decrement also. From 10 to, we start with 10, we check for certain conditions, say some condition is there, and we do it. Then we can also have I less than 4, j equal to 5, j equal to 0. So these loops, all they seems to be somewhat different than what we have learned, but they are all okay. There is no problem. This loop you can print also inside. You can scanf also. No problem at all. So these are the variations that I wanted to emphasize, that for is not following the strict rule. What all is possible can be kept inside a for. Right? Now we want to print 1 to 10. We started with I. I initialized I to 1 in the for loop. We incremented it and checked it to 10. And we printed it. See, this I equal to I plus 1. Again we have seen this can be replaced by I plus plus. These are exactly same. So this is the post increment operator or counter. So we can use this I equal to I plus 1. Again we can skip this. Why we have skipped this? Because we have used or employed it here. We have written it here. So there is no point in redundancy. So this can be also done. Here we have skipped the first part. Why? Because we have initialized the value here. So we have skipped that part. This can be also done. Now we have skipped both the parts, left hand side, right hand side, because we have initialized the value and we have incremented the value here inside the loop. So this can also be done. Here we have I equal to 0. Then we have skipped that part, increment, decrement. Why? Because we have used it here. I plus plus is simply equal to I equal to I plus 1. So this can also be done. This is also possible. Here what we have done, plus plus I. Again we have skipped this, plus plus I. We have known that plus plus I and I plus plus, they are exactly similar. Only one difference. Here first the increment will be done, then I will be assigned. Here first I will be assigned, then or I will be used, then it will be incremented. Nesting of loops. So a loop can be placed inside a loop. If loop can be placed inside while, a while can be placed inside for, a for can be placed inside if. Any combination is possible. For example, if we have say a table, we have 3 rows. This is first row till 3, 1, 2, 3. We have columns 1 to 2. Okay. Now nesting of loop, it becomes very necessary when we do advanced programming, like we are dealing with say matrix or a tabular form. Then we would require that for each row there are 2 columns. For each row there needs to be an inner loop which goes to 2 columns. Similarly, when we come to the second row, we again need 2 columns. So for each instance of outer loop, twice this loop, inner loop will be executed. This is the inner loop. This is the nesting of loop. So what this is doing, this is simply adding these numbers. Say this is 1 from 1 to 3 and this is 1 to 2. Okay. We are just adding R and C, whatever the number will be. This is just an explanation. The sum will be the row plus column. If you want to see the output, this will be like this. So the outer loop will take you to number of rows and the inner loop will take you to the columns inside the columns inside the first row. Then the loop will again, the outer loop, again the increment of row will be there and there will be the column number for the second row. This goes on. Multiple initializations for the for loop. Inside for loop, we can initialize, say we are using j and j, we can initialize j equal to 2. We can also initialize I equal to 1. This is also possible. You just have to see that you have to use a comma here, no semicolon, comma here. So this can be multiple initialization, and whenever you are into programming, proper programming, then you see this becomes very handy. The odd loop. Odd loop means when in advance you are not aware how many times you have to run a loop. Because if you are aware that I have to print number from 1 to 10, it is okay. I know the loop will run 10 times. How about when you are not aware how many times the loop will run? This is called the odd loop. So let us take an example. See, we have employed do while, and do while is employed because we want to ask user that please enter your choice. Do you want to enter or do you want to continue? He says yes. When till the time he says yes, you continue the loop, and the time he refuses, he says no, then we come out. So we have taken a character another. We'll take the choice of the user in this another. We'll take a number. This is a do while. This is an exit control loop. So the condition is not checked here. So at least one time this loop, even if the condition is wrong for the first time, this will execute once, at least once. So we enter the number. We have showed the number and the square of the number. Then we ask the user whether you want to continue. We implicitly told him that please only press Y or N. If we press yes, we check here while answer equal to Y. Then we again go back. We again go back and we perform this activity again. Then we again ask user say yes. We again do the same stuff. One time user say no or any other, because we have checked only for Y, any other character will do. So if he says no or any other character he presses, we come out of the loop. So now we are not aware how many times the user would like to continue. This is the odd loop. This is the odd loop. See, he has entered a number, you have showed the number and square. He says yes. Then you again go on till the time he says no. If he says no, we come out. So this is do while, and we will talk about do while in a great depth. Now, how to implement the odd loop using a for loop. So we have taken the character Y, we have initialized it Y, because for is the entry control loop. If the condition is not initially Y, it will come out. So you have to specifically initialize the value as yes, because you want to enter first time. Then we have not given any initialization here, because we have already initialized it here. Then we don't want to increment or decrement. This is not required, because we are not incrementing, decrementing anything. We'll be taking the user choice, and depending upon the user choice, we are going to run this for loop. Enter a number will be entered, the number and square of the number will be shown. Then if a user presses yes, we take the user input and we again check for this, whether this user has entered Y or not. Till the time he says yes, we go along and go on and on. But the time he says no, we come out. This is how we implement odd loop using for. How to use the while loop? We do the same stuff. We initialize it here. We ask for the number here. We check for the first time. It is okay. Then we enter the number, show the number and number square. Then we ask the user whether you want to continue. He says yes. We continue till the time he says no or any other character. When the no will be checked with Y, this condition becomes false and we come out of the loop. The break statement and the continue statement. See, if you are traveling from this point to this point and your intent of traveling is, I want to find out a restaurant, good restaurant. This is the destination. This is your destination. Say some X restaurant. Now when you move from this point to this point, you encounter there is a better destination or better restaurant, say Y. Then you stop here, you eat, you come back. You don't have to go to X, return to Y and do the stuff. This is the break statement. If you want to break your journey, that means if you want to break the loop in between, you use the break statement. So break will take you out from the innermost loop. It will break the loop. So let us write a number or try to find out a number, to write a program for that number, whether it is prime or not. A prime number is that number which is divisible, say 7. It is divisible by 7, that is itself, or by 1. Only this is the possibility of a prime number. So say a user enters n. What we will do? We know that 2 is a prime. We start with 2 onwards and we check all the numbers till n-1, and we take all the numbers and divide all these numbers, divide the number n by these numbers. If we find any number which divides the n other than itself or 1, we said that this number is not prime. Otherwise, if from this to this there is no number from this 2 to n-1, we are not able to find out any number which can divide n, we say that it is actually a prime. So what will we do here? We'll take modulo operator. We know modulo operator gives you the remainder. So if the remainder is 0, that means that number is divisible by the number which is dividing. So we enter a number, we take it in NUM. We start with I equal to 2. Then we say that till the time we reach the number previous to that number. So this is the number we want to reach till here. All the numbers starting with 2 till this number -1. Then we divide it. Number modulo I equal to 0. If this becomes 0, we say no, it is divisible by the number, any number which is below it. So we say it is not a a prime. So after this, what we have to do? Do we want to continue again? If we found out for 77, we found out that 7 divides it. 7 actually divides 77. So why to go to 8 or say 11? Because 11 also divides 77. Why to go beyond 7? Because we have known here that this is not a prime. So we have to break. We just break and we come out. And this number we show if at all we reach to this point NUM and there is no number we find before that which actually divides this NUM, we say that okay, the number is actually a prime number. So this is how we check. We want to emphasize only one thing here, that the break statement will break your loop. It is not necessary to continue the loop till the time it reaches the point we have initially agreed. If certain condition is met in between, we can always come out. So this break, see, we have I equal to 1, j equal to 1, I plus plus less than equal to 100, j plus plus less than equal to 200. Now we know that j is starting from n and it goes to 200. At j equal to 150, because j will reach 150, we want to break. Let us break. This is how we break. We don't want to go from 151 till 200. We just break. Continuous statement. Continuous statement means if you are traveling here from A point to B point. Now your destination is fixed. When you reach here, you found that okay, there is a dumper which has overturned. You can't take this way. So what you do? You change your route or you reroute yourself and then you go. So you skip this part. So in a loop, if you want to skip certain part, then you use continue. What continue does is, it will skip after continue whichever or how many instructions are there, they will be ignored by your for loop or any while loop or do while. Okay, I'll give you an example that this is a outer loop, this is a inner loop. We want to start from 1. Again for this 1 we go to 1 and 2. We go to 2, then again we go to 1 and 2. Then we have checked inside this loop. If I equal to j, we continue. That is when the condition 1 comes or 2 comes. That is when I become equal to j, we continue. We don't want to do anything. We don't want to print them. This is the line after continue. This will never come if I is equal to j. This will be only executed when this condition is not met. So what will be the output? See, only 1, 2 and 2, 1. 1, 1, 2, 2 will be skipped. So this is continue. Continue will just bypass, skip those lines which are after continue. Now do while loop. Do while loop is the exit control loop. Means the condition is checked here, not here. So you enter here, even if the condition is false for the first time, you execute these instructions at least once. So there is just a minor difference between while and do while and for actually. For and while, they are entry control loop. If the condition is false for the first time, you are not able to enter. You will not be allowed to enter. But in do while, you are able to enter for the first time, even if the condition is false. You start, you initialize. Then you go to the body of the loop and the increment is done here. And the testing is done at the exit point. There is no testing here. See, in the for and while, the testing is done here itself. So you execute these lines or body and then you test. So if it is true, you go again. Otherwise, you come out. So this is the first time you want to enter, say, while 4 is less than 1. Hello there. We know that 4 is not less than 1. So this print will never happen. But if we employ do while loop here, we say do while 4 less than 1. We know that this condition is false. But since we have employed do, this control will enter. This print will be printed, hello there. But the condition is false, then it will come out. So at least one time this print will be printed. Hello there will be printed. So there are certain occasions we want to at least run once the instruction. That is why we use the do while. The break and continue can be used with any construct, even with looping, even with decision control. You can use break, continue inside if also. So this break and continue, they are depending upon your program or situation, it can be used. So let us summarize. There are 3 types of loop available in C: for, while and do while. The break statement, if you want to come out of the innermost loop, the break you should use. Continue will just skip the lines which are coming after after the continue, and it will just go back again for the next iteration or next looping value counter. The do while will ensure at least one time though the statement should be executed. The plus plus operator increment the counter by 1. The minus minus will decrement the operator or counter by 1. These are all plus is equal to till modulo is equal to. These are compound assignment operator, and they modify the value of the operand on the left of them. So this is all about the very important concept in C programming, looping construct. We will be taking next discussion shortly. Till then, thank you so much. Take care of yourself.